What's up, guys? Derek, moreplates.moredates.com. Today we're going to be talking about YK11. YK11 is a myostatin inhibitor. This is going to be the most comprehensive post about YK11 on YouTube, probably on the internet in general. So it's going to get into all of the limited data on it, but kind of extrapolate it in a way that I feel will be kind of enlighten everyone on its potential applications, how it works, mechanism of action, how I feel about it personally, chemical structure, etc. So let's just get into it. YK11 is theorized to allow bodybuilders to inhibit the feedback loop in their body that limits how much muscle they can pack on via myostatin inhibition. So the end result of this could be increased muscle growth potential that would otherwise be impossible to achieve. So in this video, I'm going to break down exactly what to expect from it, how it differs from, like traditional SARMs, and what potential applications it may have. So what is YK11? YK11 is a steroidal selective androgen receptor modulator, SARM, and a myostatin inhibitor that was popularized because of its potential to induct supraphysiological levels of follistatin expression. The SARM never passed the preclinical development stage and has never been tested on humans or even animals. While there is a decent amount of anecdotal information to reference due to its popularity in the bodybuilding community, the data itself is fairly limited, and only a minority of individuals are logging their blood work consistently, and even fewer are getting extensive testing done to establish exactly what effects YK11 actually had on their body. One commonality among the majority of YK11 users is impressive increases in muscle growth, strength gains, improvements in body composition, with temporary natural testosterone suppression being the most common obvious side effect. Cellular studies conducted on YK11 suggest that it has anabolic effect on muscle tissue and bone, which is mediated through androgen receptor activation, as well as its induction of follistatin expression, which makes it unique from all of the other SARMs that you probably are aware of. It is unclear if YK11 was abandoned in preclinical development, and if it was, what that reason was. It is a very misunderstood compound, which may have some very promising applications we have yet to learn about. YK11 differs from traditional SARMs like LGD4033 and Ostrine in that it is classified as both a SARM and a steroid due to its chemical structure. It is classified as a SARM only because of the limited data that suggests it has selective activation of the androgen receptor. SARMs are traditionally non-steroidal, whereas YK11 clearly has the same chemical backbone as testosterone and DHT. Upon reviewing how YK11 was prepared, it appears to involve a combination of DHT, hydroxyflutamide, ascorbic acid, and beta-glycerol phosphate. If YK11 is a DHT derivative, we can start to piece together how it will likely perform in an anabolic and androgenic context. The term SARM can be applied relatively loosely in some contexts, and it should be noted that any compound that selectively activates the androgen receptor can technically be classified as a SARM, even if it blatantly belongs to another category of hormones entirely. A good example of this is trenbolone, which is consistently referred to in animal models for its tissue selective SARM-like effects. Like, you'll actually see trenbolone referred to as a SARM in a lot of clinical data. Mechanism of action. YK11 binds to the androgen receptors in muscle and bone in a similar way to SARMs. After binding to the androgen receptors, it exerts tissue selective anabolic activity. Given that YK11 is a derivative of DHT, it likely has some degree of antagonistic effect on estrogen. As you probably know, things like Proviron and Masteron are commonly used to antagonize estrogen and act as, functional makeshift anti-estrogen type compounds in place of AIs kind of thing. As a partial agonist, YK11 only partially activates androgen receptors and will compete directly with endogenous testosterone and DHT for receptor activation. The result of this could theoretically be a decrease in muscle size and strength should YK11 displace endogenous testosterone to enough of a degree. Of course, this would vary based on the dosage of YK11, the amount of endogenous androgens in the body, the amount of synthetic exogenous androgens in the body, and how YK11 actually works on a cellular level. One of the mechanisms through which YK11 facilitates its effects after binding to the androgen receptor is by inducing greater expression of follistatin. So YK11 induces the muscle cells to produce more follistatin, consequently inhibiting myostatin in the body, which could then result in overall more muscle growth. The anabolic capabilities of YK11 could be largely mediated by its induction of increased follistatin production, and the extent to which this occurs remains unknown. Despite YK11 being a derivative of DHT, YK11 induced follistatin expression while DHT did not. The anabolic effects of YK11 were reversed with an anti-follistatin antibody, thereby suggesting that the effect YK11 has on muscle growth is largely mediated via its induction of follistatin. To date, no other anabolic hormone is capable of inducing follistatin production the same way YK11 can. So what is follistatin? How does it affect muscle building? So follistatin is a protein that acts as an antagonist to myostatin in the body and is arguably one of the most critical factors that will determine how much muscle somebody can build, essentially. While follistatin is naturally occurring in the body, it is theorized that by increasing those levels in the body, you could inhibit more myostatin, which would consequently remove the limitations your body sets on muscle growth. Myostatin inhibitors have been proposed by many to be the most promising new area of science in a bodybuilding context, as well as potentially better alternative treatment for muscle wasting diseases. Follistatin was first popularized when it was discovered that it quadrupled the muscle size of myostatin deficient mice. Mice that lack the gene that creates myostatin have approximately twice as much muscle mass as normal mice. Mice that lack the gene that creates myostatin and overproduce follistatin simultaneously have approximately 4 times as much muscle mass as normal mice. Follistatin increases muscle mass via another pathway as well that does not involve myostatin inhibition, but that pathway, whatever it is, remains unclear. 99.9% of follistatin is fake, so I highly recommend that you do not waste your money buying vials of follistatin from research chemical websites. It's always bunk, and companies often take advantage of the hype around it by selling it at obscenely high prices. Myostatin and how it affects muscle building. So myostatin is a protein in the body that acts as a regulator of skeletal muscle mass, limiting how much muscle the body can grow. Interestingly enough, genetically gifted bodybuilders have been found to have very low levels of myostatin in their bodies, which we can surmise is the reason why they have such a remarkable ability to pack on muscle. And in addition to androgen receptor sensitivity and things at the androgen receptor level, of course, as well. But, you know, I think one of the main reasons is myostatin gene polymorphisms and stuff like that. Supposedly, Flex Wheeler in particular, which is, you know, obviously one of the greatest bodybuilders of all time, was a participant in a study in collaboration with the Department of Human Genetics at the University of Pittsburgh involving 62 men. All of these men made unusually large gains in muscle mass in response to strength training, and which is why they were involved in the study. When the results came in, Flex Wheeler was revealed to be one of only 9 extreme responders that had a very rare myostatin mutation at the exon 2 position on the gene. This is the rarest myostatin mutation found in humans, and the result of this mutation is a much larger number of muscle fibers than in the average male. What is a myostatin inhibitor? So as myostatin keeps your body from growing too much muscle, a myostatin inhibitor would be a compound that could inhibit myostatin from acting on muscle cells, thereby allowing you to greatly surpass your previous muscle building threshold. The YK11 is a myostatin inhibitor because it induces greater levels of follistatin expression, and in theory, by increasing follistatin expression, YK11 could indirectly inhibit myostatin and facilitate anabolic effects in the body far greater than would be possible otherwise. So getting into the YK11 reported effects, muscle building. There are no animal or human trials to definitively state that YK11 has any effect whatsoever. However, in its cell-based studies and in hundreds of anecdotal logs, it has exhibited a fairly substantial anabolic effect on muscle growth. The mechanism by which YK11 facilitates its effects is different than the more mainstream SARM, steroids, or HGH. Because of this, it is theorized that YK11 could be added to any performance-enhancing cycle for additional muscle growth and anabolic synergy. Myostatin inhibition. By facilitating an increase in follistatin expression, YK11 will inhibit myostatin, which may allow the user to surpass their genetic limit in terms of accrual of muscle mass. Bone formation. YK11 upregulated osteoblastic proliferation in a cellular study. Osteoblasts are cells that develop bone. By rapidly increasing the number of osteoblasts, YK11 may be able to prevent or help prevent and reverse bone-wasting diseases. This function makes YK11 a promising SARM for osteoporosis and other androgen deficiency-related diseases. Muscle hardening. So as YK11 is a DHT derivative, it's reasonable to assume that it may share the same attributes as other more traditional DHT derivatives like Masteron. Typically, DHT derivatives don't have a significantly anabolic effect on muscle growth, but instead are potent strength builders and muscle hardeners. They are generally very dry and will excel far more in their ability to increase strength, their cosmetic effects they have on muscle, as well as the antagonistic effect they have on estrogen. YK11 mediates its anabolic effects through follistatin expression, so it is possible that it will not only induce the same muscle hardness and strength benefits that DHT derivatives are known for, but also increase muscle mass substantially more than a traditional DHT derivative. Sex drive. DHT derivatives are generally very androgenic and will increase libido and penile sensitivity. For example, proviron is a modified derivative of DHT synthesized by adding a methyl group on the first carbon of DHT. It is extremely androgenic, but it has nearly no anabolic effects in muscle mass despite it being an anabolic androgenic steroid. If YK11 acts the same way other DHT derivatives do, it is plausible to assume that it may induce similar effects on penile sensitivity and libido. YK11 reviews, so these are anecdotal recreational reports. So YK11 is reported to produce lean, dry gains with the exception of hair loss. Reports of other side effects from YK11 are typically less prevalent than with the more mainstream, very suppressive SARMs, and this may be due to its close resemblance to DHT. So DHT and its derivatives antagonize estrogen and can offset testosterone suppression-related side effects to a fair extent due to their inherent androgenicity. In other words, they have shown to essentially fill the androgenic void to some extent that lowering endogenous testosterone and DHT will cause, as well as, knocking them off the androgen receptor with things with high binding affinities like SARMs. While there are an insufficient amount of androgens present, many androgen-dependent functions are inhibited, including but not limited to inhibited penile sensitivity and libido. YK11's chemical structure differs greatly from that of SARMs and resembles the chemical structure of DHT, dihydrotestosterone, very closely. It may be more accurate to say that YK11 is a steroid or a derivative of one rather than to say it is a SARM. Unfortunately, it's pretty unclear exactly what it is, as it's very new on the scene, and most of the conclusions being drawn about this compound are just based on personal opinion rather than actual science. So one thing we do know is that the unique effect YK11 has on follistatin expression is completely unlike any other SARM. Anecdotally, YK11 exhibits a blatant anabolic effect and has muscle building potential. However, it doesn't seem to produce any mind-blowing muscle growth that would not be achievable with other far more thoroughly studied anabolic agents. Personally, I have yet to see one person take their physique to a new level solely from YK11, and it certainly has not produced any flex wheelers. With that being said, without human trials, there is no way to actually assess how much YK11 can inhibit myostatin in humans, if at all, and if there is a dosage that could equate to the same level of myostatin inhibition that a genetic anomaly with a gene mutation has. YK11 isn't necessarily better or worse than any other SARM, but this is because it operates via a completely separate mechanism of action for inducing muscle growth, or at least the main mechanism for which it would be incorporated into some sort of protocol. Because YK11 induces muscle growth via a completely separate pathway than other anabolic steroids or SARMs, it would be more productive to figure out what would work best alongside it, or if it is even worth exploring in the first place, rather than trying to figure out if it's stronger or weaker than other anabolics that induce muscle growth in a totally different manner, or that just aren't able to produce the same, mechanism of action that YK11 can. So YK11 side effects. So testosterone suppression. YK11 suppresses natural testosterone levels in a dose-dependent manner, the same way anabolic steroids and SARMs do. This occurs via the suppression of luteinizing hormone and follicle-stimulating hormone through the HPTA. While there have been no studies to test this specifically, anecdotal reports with blood work confirm that YK11 is indeed suppressive, and it is extremely unlikely that YK11 would be the only steroid or SARM that wasn't suppressive. Liver toxicity. YK11 features a methyl ester, which inhibits its hepatic metabolism and is what makes it orally bioavailable. The drawback of orally active methylated steroids is that they are typically very liver toxic, and essentially they need to be liver toxic in order to prevent their breakdown as they pass through the body. Anecdotally, YK11 has exhibited transient increases in liver enzymes. The chemical structure and anecdotal reports suggest that YK11 exhibits at least some level of hepatotoxicity. Hair loss. Anecdotally, reports of hair loss from YK11 are fairly common. This is not surprising at all to me, though, as DHT derivatives in general are the worst offenders when it comes to hair loss potential. Joint and tendon weakness. Anecdotally, some users have reported joint pain while using YK11. DHT has been shown to interfere with cortisol secretion, and certain DHT derivatives are notorious for interacting with binding proteins that inhibit proper cortisol regulation. Winstrol in particular majorly impacts cortisol regulation and results in severe joint pain in some users. YK11 is a DHT derivative just like Winstrol, so it's possible that YK11 could be interfering with pathways that facilitate proper cortisol secretion, thereby causing joint pain in users. Also, myostatin is expressed in tendons and appears to play an important role in tendon maintenance. Myostatin deficient mice have been found to have weak and brittle tendons. This suggests that YK11 may have a negative effect on tendon strength as a consequence of myostatin inhibition. Aggression. DHT derivatives are commonly used in a performance-enhancing context pre-workout for a quick boost in aggression. This aggression derives from their androgenicity. Users report blatantly increased levels of aggression on YK11, and this may be a result of YK11's chemical similarities to DHT and its derivatives. Half-life. The half-life of YK11 is unknown at this time, so trying to speculate of, how frequently needs to be dosed or whatever, it's kind of useless at this point because there's no trials on humans or even animals to even evaluate at some reference level what its pharmacokinetics and pharmacodynamics look like. So that's pretty much as we know about YK11. Interesting, very interesting compound to say the least, but it's nothing I'm going to be slamming my body with anytime soon, especially when there's efficacious alternatives that produce, better return on investment for the risk profile you're putting your body through. So anyways, that's all the data we have on it. Kind of a comprehensive overview, if you will. If you like this video, please drop a like, please comment. Check out my blog, moreplates.moredates.com. Subscribe there on the opt-in on the right-hand side or on the pop-up. Check out my Instagram at moreplates_moredates. Follow me there for stories and updates and whatnot that I don't post on YouTube. Snapchat, Facebook, Twitter. Check out my links in the video description below for ways to support me and products I formulated myself, like my turnkey nootropic formula, Gorilla Mind. Also, check out the podcast on iTunes. It's linked in the video description below as well. If you drop a 5-star rating, it really helps push my content to people who haven't seen it before, and it's really much appreciated when you guys do that. So thank you guys for watching. Talk to you soon.